Alright, so today we are going to discuss about practice problems based on protection and deprotection of alcohol functional group. But before I begin, I would strongly recommend you to watch my previous video where I talked in detail with mechanism all the strategies related to protection and deprotection of alcohols so that you will be able to solve problems by yourself. Okay, so let's begin. So the first problem is we have this particular starting material and we are reacting this with this particular reagent in presence of HCl in catalytic amount. We have TCM as a solvent. We are keeping this reaction for 12 hours at room temperature. So what is the product? Okay, so we can write this molecule as Cl3C. This is another carbon bonded to NH, and we have this OBN group. I can write this OBN as OCH2PH. So this oxygen lone pairs will attack at this carbon. This carbon oxygen bond is going to break, will form a double bond here, and this double bond will take the H plus ions coming from HCl. So the product is going to be so this oxygen is now bonded to CH2PH. So this is my main product. So we are simply protecting our OH group with a benzyl group, right? And the byproduct is this is the byproduct. So now let's move forward for the second question. Okay, so for second question we have, this time we have a primary alcohol bonded to this particular lactone type of system, and the reagent we are using is same. We are using Cl3C, C double bond NH, OBN. We are using HCl in catalytic amount. We have DCM as a solvent at room temperature. This time we are keeping for 24 hours. So what is the product? Once again, the mechanism is going to be the same. We are going to protect this OH group with a OBN group. So the product will be, so this is my product. What we have for the third question? So this is my starting material, and I'm reacting this molecule with tretyl chloride. What is a tretyl chloride? That is nothing but PH3CCl. We are using triethylamine as a base. We are using DCM as a solvent. So what is the product? Well, if you have watched my previous video, you must be knowing that this tretyl chloride is very selective for 1 degree alcohols. Okay, and here we have a 2 degree alcohol and a 1 degree alcohol. Suppose if I have just one equivalent of tretyl chloride, we are going to protect the 1 degree alcohol only. So the product will be, we will not touch the secondary alcohol, and we will protect the primary alcohol with a OCPH3. Okay, that is nothing but O tretyl group. So this is the product. Okay, so for the fourth question, we have a cyclopentane ring So this is protected alcohol group, which we will discuss in future videos. Here we have a OBN group, and here we have O tretyl group and OTBS group. So we have all this protection. when we react this with formic acid and water. So what is the product? Well, this BN group deprotects under H2PDC condition. This TBS deprotects in presence of F minus salt. But this trityl group is very labile to acid. So this will be deprotected selectively. And the product will be this will be untouched. Here we have converted OTR to OH and this will be intact. So this is the product for this reaction. Okay, so for the fifth question we have a ethyl alcohol and we are reacting this with TMS OTF in presence of imidazole and we have DMF as a solvent. We are keeping this for 3 hours at room temperature and we are getting A. Then further we are reacting this with TBAF and we are getting B. So find out A and B. Okay, so we know TMS OTF is nothing but the trimethyl silyl group. Okay. Now this oxygen lone pairs will form a bond with silicon and OTF is going to leave. So the product A will be OTMS. That is nothing but O bonded to silicon bonded to 3 methyl groups. Now the second reagent we have is a TBAF. TBAF is tert butyl ammonium fluoride. So it gives out F minus ions. And that is what we want to deprotect silicon group. So this F minus will bond with silicon and this bond is going to break. This bond lone pair will collapse on O minus and we are going to deprotect OTMS group and the B product is going to be once again the ethyl alcohol. So this is another deprotection by using TMS group. So we protected our OH with OTMS using this TMS OTF where OTF is leaving as a OTF minus and we are generating this CH3 CH2 OTMS. Furthermore, to deprotect this OTMS back into OH, we are using TBAF, that is nothing but tert butyl ammonium fluoride, which gives out F minus ions and we will get the product B. So this is my A and this is my B. Okay, now sixth question. So this is my starting material. Above the plane we have OH group. Okay, so above the plane we have an OH group. When I react this with MCPBA, okay, we will discuss all this particular reagent in our future videos. So for time being, you just remember that MCPBA is nothing but the source of oxygen atom, and this double bond will form a epoxide here. Okay, and this MCPBA is able to do hydrogen bonding. So as this OH group is above the plane, this MCPBA will insert the oxygen from above the plane. Okay, so this MCPBA provides oxygen atom, converts alkene into epoxide and is able to do hydrogen bonding. So just because this OH group is above the plane, it's going to do hydrogen bonding above the plane and will provide oxygen from above the plane. Okay, suppose I'm doing for the same starting material, I'm using this TBDMS chloride, okay, in presence of imidazole. So we know this TBDMS, that is tert butyl dimethyl, will protect this OH group. So this time we converted OH into OTBDMS by using this particular reagent. Now this time if I subject this to MCPPA, okay, so I converted OH into OTBDMS. So this time the MCPBA will not be able to do hydrogen bonding, and this time it will insert oxygen below the plane. Okay, I hope I'm clear that this time I converted OH into OTBDMS. I removed the hydrogen, so MCPBA will not do hydrogen bonding and will insert the oxygen below the plane. Now let's get back our OH group by using TBAF. So convert your OTBDMS back into OH using this TBAF molecule, and you will be able to form this molecule. Okay, so now you know that how to convert this particular molecule and insert oxygen above the plane and below the plane by changing your reagents. Okay, so this was the sixth problem, very interesting problem. Okay, so seventh problem. This time we have a secondary alcohol and a primary alcohol sitting on the same molecule, and we are reacting this with TBDMS chloride and imidazole as a base, DMF as a solvent, and you are using just one equivalent of this TBDMS chloride. So what is the product? Okay, so we know that when you are breaking, just to recall, when you are breaking this particular bond, okay, I have discussed this in my previous video. So when you are breaking this particular bond, the order of reactivity is 1 degree, then 2 degree, then 3 degree. So when we are protecting any alcohol group with any functional group, we are simply breaking this bond. Okay, so we are converting OH into OR or any OTBDMS. So we are breaking this bond. So the order of reactivity is 1 degree followed by 2 degree followed by 3 degree. So just because we used only one equivalent, secondary alcohol will be untouched and only primary alcohol will react. So the product will be OH, and we are converting OH into OTBDMS just because we used TBDMSCl. So this was my seventh problem. Okay, so for the eighth problem, I have this cyclopentane ring. We have a double bond here. We have a OTBS group, or people also call it TBDMS. So here we have a TBDMS. Here we have a double bond. We have CO2Me, an ester group. And here we have OTBS. Okay, and if I am reacting this molecule with hydrogen fluoride and ACN mixture, ACN is acetonitrile. So what is the product? Once again I see HF, a F minus. So I know F minus is used to deprotect Silyl functional group. Well, I have two Silyl functional group, so I am simply going to deprotect them. Stereochemistry will not change because we are not doing any reaction at stereo centers. So stereochemistry will not change. So this is my product of this reaction. We simply deprotected both the TBS or TBDMS group by using this particular HF-ACN mixture. Okay, so for the ninth problem, we have so many functional group this time. Okay, we have OTES group, we have OMOM group, we also have protected alcohols. Then we have OAC group. We also have OTBS group. Fine. So these are all the protected alcohols we have, and just we are using is one equivalent of TBAF group in ACN. So what is the product? So feel free to pause the video and try to solve this reaction. Okay, so as a reagent I can see TBAF group. I know it will give me F minus, and I know F minus it is used to deprotect Silyl functional group. So here I have a Silyl functional group and here I have a Silyl functional group. Well, the mom group is deprotected under Lewis acid condition. We do not have a Lewis acid here. The acetyl group is deprotected under strong basic condition. Well, we do not have it. We don't have it. And this is also deprotected under acidic or basic condition, particularly acidic condition, which we are going to see in detail in future videos. So for time being, we know we have a TBAF group and it will give me F minus and it will deprotect the Silyl group. But which Silyl group? Because I have only one equivalent of TBAF group. So just to recall, for the Silyl protected ether, okay, we know that more bulky will be more stable. Okay, we have already discussed this in my previous video that Silyl protected ether, if it is more bulky, it will be more stable. So it will not cleave first. Do not cleave first. So out of TBS and TES, which is bulkier? Well, TES is triethyl and TBS, or you can also call it as TBDMS, is dimethyl tert-butyl. So clearly this is more bulkier. So this will be stable and it will not deprotect. Rather, TES will deprotect under TBAF condition. So the product will be So I'm going to just deprotect OTS back into OH by using this one equivalent of TBAF group. We cannot deprotect mom group because this cleaves out under Lewis acid condition. We do not have it. This will also be untouched as this is deprotected under acidic medium. We will not touch OAC group because this is deprotected under strong basic condition. And this will intact simply because this is bulkier and more stable, and also we have just one equivalent of TBAF. In case if we have two equivalent, then we will convert this OTBS back into OH. So this is the product for this reaction. Okay, so let's solve more problems based on the selective protection and deprotection. So next question, the 10th question we have is, we have this particular ring. Here we have a mom group, mom protected alcohol. Here we have a THP protected alcohols, and we have a OTBS group. So this is my starting material. Fine. I'm reacting this with TBAF. Okay, just one equivalent of TBAF. Then I'm reacting this with acetic acid and water THF mixture. Well, water THF mixture is just a solvent. You need to focus on this acetic acid. And third we have is zinc bromide as one of the reagent. So pause the video and try to solve and try to find out all these three reactions product. Okay, so we have a mom group, we have a THP group, and we have a TBS group. Fine. The first reagent uses a TBAF. It gives out F minus, and we know F minus is used to deprotect Silyl group. Out of these three, this is my Silyl group. So I'm simply going to deprotect it, and the product will be OTHP will be intact, OMOM will be intact, and this OTBS will be converted into OH. So this is the product for the first reaction where we are using TBAF group. Now in the second condition, we have an acetic acid. So this TBS is deprotected under F- condition. To deprotect THP, you need a acidic media, and we do have acidic media. So I'm going to deprotect THP this time. MOM is unaffected under acidic condition. So MOM will be intact. So this time we'll convert THP into OH because THP is very labile to acidic media. So this is the second product. And for the third condition, we have a zinc bromide. TBS deprotects under F- source, THP deprotects under the acidic media, and we know that MOM deprotects under Lewis acid condition, and this zinc bromide is a Lewis acid. So this time we'll deprotect the MOM group and will convert into OH. So this is the product for the third step, the third reaction. Okay, so when we have F-, we deprotected OTBS. When we have acidic media, we deprotected THP group. When we have zinc bromide as a Lewis acid, we deprotected MOM group. So this is what we call the selective deprotection, because we have 3 alcohol protected groups, but we are selectively deprotecting one of the OH group. So this kind of reactions are very important for your exam perspective. Okay, let's see the 11th question. We have this OTHP group and we have OMEM group, and we are using acetic acid and water THF mixture at 36 degrees Celsius. So what is the product? This MEM group is deprotected under Lewis acid condition, and this THP is deprotected under acidic media, and we do have acidic media. So I'm going to selectively deprotect this group, and this will be untouched. So the product will be this will be back to OH, and this will remain the same. So this was my 11th question. For the 12th question, okay, this is another TMS group, but this is not OH TMS. This is a carbon silicon bond. So this is not a protected alcohol. Okay, we have a free alcohol here, and we are reacting this with acetic anhydride in presence of triethylamine as a base, and we are using DMF as a solvent. So what is the product? We know that alcohol can be protected into OAC using acetic anhydride or acetyl chloride. So this is what we are doing here. We are simply protecting OH into OAC group by using acetic anhydride, and this is the product. Acetyl group represents CH3 and carbonyl. That's it. So this was the product for the 12th reaction. Okay, so for the next reaction, we have a secondary alcohol. We have another secondary alcohol, and we have a primary alcohol, and we are reacting this with tert butyl acyl chloride using pyridine as a base, DCM as a solvent, and we are keeping it at 0 degrees Celsius. So what is the product? Okay, so once again we have comparison between secondary alcohol and a primary alcohol. So this is my primary alcohol and these two are secondary alcohols. So once again we know that 1 degree alcohol is more reactive than 2 degree followed by 3 degree when we are doing protection of alcohol, simply because we are breaking this bond. In case if you want to break this bond, the order of reactivity will be reverse. Okay, so we know that 1 degree will be more reactive than 2 degree followed by 3 degree. So only 1 degree alcohol will be protected. Now what is the third butyl carbonyl chloride? So this is how I can represent it. Okay, so this is how I can represent it, the third butyl COCl. So this oxygen lone pairs will attack at this carbonyl. Through conjugation, Cl is going to leave, and what we have formed is, so this OH is intact, this another OH is intact, and we have converted this OH into this particular group. So we connected this oxygen with this carbonyl by eliminating Cl group, and this is what we formed. And this also can be written as OH, OH, O, and this whole group is what we call the pivylate ester. So I am going to write PIV as a short form. So you know that PIV represents the carbonyl attached to third butyl group. So this is the product for this reaction. Okay, so the last question we have is related to carbohydrates. So this is my one of the sugar. Okay, we have a OMe group here, we have a free alcohol, secondary alcohol here, another free alcohol, and we have a CH2OH group at this position, and I'm reacting this with acetyl chloride, just one equivalent, and using pyridine as a base, THF as a solvent. So what is the product? Once again we are simply doing the protection of OH group into OAC group by using acetyl chloride. So we know the order of reactivity will be 1 degree followed by 2 degree followed by 3 degree. So here we have a 2 degree, 2 degree, 2 degree, and we do have a 1 degree alcohol. So, and we have one equivalent of acetyl chloride. So I'm simply going to protect my primary alcohol into OAC, and the product will be rest group will be intact. I can write this OAC in a full form like this. Okay, so this is the product for this reaction. We are converting OH into OAC. AC represents the acetyl group. By using acetyl chloride, we are using one equivalent. So out of all these alcohols, only one will be protected. And we know that we need to protect 1 degree alcohol because when we are doing protection, 1 degree is most reactive. So this is the product for this reaction. Okay, so that's it for today, and thank you so much for watching.